In this tutorial, I'm showing you how to use a Venn diagram to assess the validity of a categorical syllogism. So first, a quick review. What is a categorical syllogism? It's an argument form composed of three categorical propositions, three terms. Each of the terms is used exactly twice. So remember, we have a subject term of the conclusion, predicate term of the conclusion, and the middle term that appears in each of the two premises. Everything in a categorical syllogism is named based on the conclusion. So let's say the conclusion is all S is P. Then in the minor premise, you'll have the minor term like this, all S is M. And in the major premise, you will have the major term, all M is P. This is a form that should be familiar to you. It is the Moodin figure A1. That's because we have an A as the major premise, an A type as the minor premise, and an A as the conclusion, and also the middle term is in the first figure. So this is the Moodin figure, A1. All right, now we're ready to start learning how to diagram categorical syllogisms. All right, now let's turn to diagramming categorical syllogisms using Venn diagrams. The approach is basically 5 rules, starting with a step 0, which is we always use the same empty schema. And that schema looks like this. Here we have 3 circles overlapping. Across the top, where we have 2 circles, we have the minor term, that's the subject term of the conclusion. We have the major term, that's the predicate term of the conclusion. And hanging here from the bottom, we have the middle term. The middle term mediates a relationship between the subject and predicate of the conclusion. And so it's called the middle because it stands in the middle between S and P. All right, now that we have the empty schema, there are basically 4 steps to follow. So in step 1, we put on the diagram all the shading from the premises. So you'll remember from our examination of categorical propositions that it's the universal propositions, A's and E's, universal affirmative, universal negative, that involve shading. So if you have shading in the premises, you will put the shading on first. Second, you will add definite X's. These are X's where it's obvious which region the X has to go into. Usually that's going to be because of shading. We'll talk more about that in a minute. And step 3, we put indefinite X's. Indefinite X's are X's that belong in some overlapping region and we're not sure where they belong. I'll show you some examples of that. And then finally, there is the double duty rule, which says that a definite X can do double duty for any other X. So if you learn this process in order, you're not going to go wrong. If you take these steps out of order and you put an X on before you've done the shading, it may be impossible for you to tell whether you have a definite or an indefinite X. So those are the rules. Same empty schema that we're looking at here. Put all the shading from the premises, definite X's, indefinite X's, and then have a look for the double duty rule. One reminder, you never want to diagram information from the conclusion, because if you put information from the conclusion on a diagram, then the diagram will always show that the conclusion is already captured in the diagram, right? Because you've put it there. So be sure you diagram only information from the premises.